Hello everyone. In this whole video we will discuss on flags of IP header. Now we have discussed more concept of IP header in previous videos where we have discussed version, field, IP header length, type of services, total length, identification number. Now this time for flags. So let's start. Here look at this field. Flags is used and is known as control bits, is known as control flags. Clear? So we can say that it is a control flags. Now names gives every information because in TCP header we used flags. That means it is a symbol only. This decides what is working in processing of any packet. Clear? Now this is a 3-bit field. This is a 3-bit field. So first we should write here 3-bit, and that means this will be 13 bits because this total will be 16 bits. Now these 3 bits, first we should differentiate this control flags here. Clear? Now these 3 bits here, first it is not used. First is not used, so we will denote as a X. Now second is don't fragment bit, so we can say that this is DF, and last one is more fragment bits. So what is this DF? Don't fragment. Clear? Don't fragment. Here more fragment. So names gives the information about something is symbol, something is used as a representative member, like as a parliament. Clear? More fragment. Now so in bit field there are 2 numbers only, but this field, this first bit field is not used, so it is reserved. It is reserved. So if do not fragment has, if you say here 2 bits, one is 0, one is 1, here we will never use, so always 0 is used here. Now for more fragment we use 2 bits, one is 0, one second is 1. So there are 2 ways. Now what do you feel if DF is 0? That means do not fragment is opposite, because that means we can say may fragment. If DF 0 here, because don't fragment, that means don't fragment is not applicable if we use 0. That means there is happening fragments So df equal to 0, that means just like think about this. Sometimes this is a negative term, this is a negative term, and in negative term, if we use 0, that means we are providing positive attitude, we are providing positive attitude. That means if df equal to 0, that means there are fragments available, there are availability for fragments. Clear? And if we use df for 1, that means true. Do not fragment, this term don't fragment, that means it is true if we use 1. If we use 1, that means it is true, don't fragment, that means there is not availability for any fragments. Clear? So there are 2 bits. Here we should write in this way, like this. df, if df equal to 0, what is the meaning? That means may fragment, may fragment. That means fragment the packet, divide the packet. This is it. Now if df is true, that means 1, this is off bit is used. Here df flag, if df flag is set by 1, then that means it gives information about the fragmentation. That means if it is set by 1, that means generally we use the same term, don't fragment. So we can write here don't fragment, no fragmentation, so something like that, don't fragment. Now this is the whole concept about don't fragment. Now move on this point, more fragment. What do you understand? If this flag field more fragment is set by 0 or set by 1, what do you understand? That means more fragment set by 0, what do you understand? More fragment is 0. That means this is the last fragment, this is the last fragment. More fragment is 0, that means off, we will never use, we do not need any fragment, so we will use 0, we will use 0. So we can say that if more fragment field is set by 0, that means this is a last fragment, this is a last fragment. Now if more fragment field, flag field, control bits field is set by 1, that means on, that means what is the basic phenomena for this field, then we will use, because this field for more fragment, so it is on, so there is, we will have more fragment, that means we want more fragment. Clear? So we can say that if mf equal to 1, that more fragment. Clear? Now this is the whole information about more fragment. Now for this field set by 0, which is reserved, that means it is used in future. Clear? This is whole information about control flags, that means flag bit, which is 3-bit field. Clear? Which is a 3-bit field. Now here we will tell you about some interesting concept. Suppose this is a router. This is a router 1 and this is a router 2. Clear? Here senders will send a packet on the basis of MTU of a receiver. How sender knows about this MTU size? On the basis of when we establish connection, acknowledgement, there is a more other packets is also available, window size. Then on the basis of this we can know about the neighbor devices. Clear? This is a sender and this is a receiver. So suppose this MTU is a MTU for this sender, this is a 1500, and MTU for this is, suppose that this is a 500. Clear? Now then here if sender sends any packet, then it will be fragmented. It will be fragmented in 3 portions. So first one is 500, second one will be 500, third one will be 500. Clear? So this is the sender will send the packet and it will be fragmented in 3 fragments. Clear? That means each fragment will use identification number, ID. Here we are using ID for identification. For identification, according the definition of identification, what you understand, it should be the same value for each fragments. Clear? So we will use 5. Suppose we are using 5 number as randomly we are choosing, but it should be same. Now this, that means there are more fragments. Suppose this is a first, second, third, or we can say that first, second, third, whatever you want, because it is only assumption. Clear? Now here DF and MF. So for this, what do you understand? Here do not fragment is not possible. That means here fragmentation is available. That means then DF will be 0 because fragmentation is happening. Clear? Fragmentation is happening. Now then MF more fragments field will be here 0 and 1. That means last fragment, or which will be last fragment, which will be the more fragment. That means if this is a first, this is a second, this is a third. So if more fragment set by 1, that means mf, if mf1, that means there we want more fragments. That means something available, that means there are fragments is available, and here that means second fragment will be also 1. Clear? Now no more availability for any fragments, so we can say that this field should be as a 0. So just as a identification number, just as a recognition, that means you can count on the basis of more fragments field, because here 1, that means there something other fragments also available. So here you get 1, then that means you can say maybe one fragments also available. So here you are getting 0, that means no more fragments is available here. Clear? So this is the whole information about the fragmentation of packet. Now if this is not a big scenario, you can assumption, suppose at application layer there is a bulk chunks, that means a big data, and this big data comes at here, big data is, then it will come at application transport layer, and transport layer segment this in a separated form. This is called in small chunks, and in small chunks is defined as a segment. This is a segment. Clear? Now this segment is handovered by transport layer protocol and is received by network layer protocol IP header. Now here each segment is again on the basis of MTU size of neighbor devices, it fragments this. Suppose this is a here. Now for identification we generally use, suppose here 1 1, here 2 2, here 3 3. Clear? Now for this is used for identification. This number is denoted by identification. Now here for MF, that means we are fragmenting, so here first is 1, second will be 0, because this is whole this is a whole packet, and this packet is divided into fragment. Clear? Now here 1, here 0, here 1, here 0. This is the whole information about. Clear? I think you are understanding about this. Clear? Now in next video we will tell you about fragment offset. Then you will be able to understand the whole row identification, flags, and fragment offset. So thank you guys for your dedication. We will meet you next video.